This is R.D. Sharma solution, class 12th, chapter 19, exercises 19.13. Indefinite integrals we are talking about. Now this type of questions, we'll see that we have to put this x as something so that we can get an integrable or possibility of integrability. So this x square is in the numerator. Denominator we have a square minus x square. So we will use the trigonometric identities and equations to resolve this. For that we will put x equals to a cos theta. The question will arise why we are not putting x equals to a sin theta. That you will see in the coming questions. Because we know that sin square theta plus cos square theta is equal to 1. So we can have sin square theta as 1 minus cos square theta and cos square theta as 1 minus sin square theta. So in place of x square we are writing this a cos theta whole square. So this will give you a square, we can take common, 1 minus cos square theta. 1 minus cos square theta will be sin square theta, and this is your denominator. But since the power is 3 by 2, so what do we get? The power is 3 by 2. And the power gets multiplied, 2 into 3 by 2, 2 gets cancelled. So this will form a sin theta whole cube, or you can call it as a cube sin cube theta. What is upstairs now? In place of x square, what we are going to put? It's a cos theta whole square, a square cos square theta. Denominator we have a cube sin cube theta. Now when you want to integrate this, now I've just resolved it using x equals to a cos theta. In place of dx also we would like to put something, because that has to be replaced. So when you differentiate x equals to a cos theta, dx by d theta will be negative a sin theta. So dx can be replaced by now minus a sin theta d theta. That you can write now. So integration of a square cos square theta by a cube sin cube theta was already there. So this term was already there. The second term, or the replacement of dx, we are going to write it here. Negative a sin theta d theta. Okay, let's do some cancellations now and find out whether we can get something which can be integrated. So we have cos square theta and sin theta. One sin theta you can just cancel it out from the denominator. So we have cos square theta by sin square theta. That amounts to cot square theta. Cos by sin is cot and square is cot square. So minus integration of cot square theta has come. Now cot and cosec has a relationship. Same as sec and tan has a relationship. So cot square theta is cosec square theta minus 1. And there is a negative already there. Everywhere d theta is there. So this will be, if you multiply negative inside, it will be 1 minus cos square theta. So we have to integrate this separately. Integration of the d theta minus integration of cosec square theta d theta. So integration of d theta will be what? It will be theta. And this is negative, because cosec square theta will give you minus cot theta. So negative will become positive. So theta plus cot theta, theta plus cot theta plus constant of integration. Now this will not be an answer because theta has to be replaced, because theta we have introduced. So this is our responsibility to remove it also. So when x equals to a cos theta will be x by a. Theta will be cos inverse x by a. So wherever we have theta, we have to replace it by cos inverse x by a. So cos inverse x by a plus cot theta, so cot, and this will be theta will be cos inverse x by a. So just write this cos inverse x by a inside. Cos inverse x by a I am writing, plus constant of integration that will be. But still we are not satisfied, because cot and cos inverse, this can be resolved. Cos inverse x by a is final, but the second term I am talking about, cos inverse x by a. So cos inverse in terms of cot inverse can be written as cot inverse x by under root a square minus x square. So in the beginning of this exercise, all these R.D. Sharma relationships are given in this book of R.D. Sharma. So you can just refer to that. X by under root a square minus x square. Cot inverse. Cot is already there, so cot and cot inverse gets cancelled. So the final answer will be cos inverse x by a plus this gets cancelled. You have x divided by under root a square minus x square plus constant of integration. That's your final answer. So this is the reference I was talking about. And since the basics we have understood, now you know how to resolve these kind of questions. So we have x raised 7 divided by a square minus x square to the power 5 now. So x can be written as a cos theta, x can be written as a sin theta. So x equals to a sin theta now we are placing. Dx by d theta will be what? It will be a sin theta will be cos theta. Dx will be a cos theta d theta. First thing will be this one. What will be the second one? This sine theta will be x by a from the first one, first assumption. Theta will form sine inverse x by a. This we are going to use in the later part of this question. Numerator, denominator. Let's resolve the denominator first. The downstairs first. So x square minus x. This x has to be replaced by a sine theta now. A square minus a square sine square theta. A square you can take common. 1 minus sine square theta is cos square theta. So a square cos square theta you got. Now power is 5 here. The power 5 means a raised 10 and cos raised 10. That's the power 5. So a raised 10 and cos raised 10 theta it will be. Now let's use the numerator and denominator together now. So x raised 7 is, because x was a sine theta, so a sine theta to the power 7. That is a raised 7 sine raised 7. Denominator you have this a raised 10 cos raised 10. So a raised 10 cos raised 10, I am writing it in the denominator. When we integrate it in with respect to this, not dx but d theta we have to use. So what will be this? Dx in place of dx I am writing a cos theta d theta. So this will be a cancellation. A7, A10 and a. So the numerator has a raised 8, denominator has a raised 10. So denominator will be 1 by a square, and this integration. One cos you can cancel here. One cos you can just cancel it out. So cos raised 9 theta it will be. Sin 7 and cos 9. So sin 7 by cos 7 you can write, and one more cos square you can separate them out. So sin 7 and cos 7 is 10 raised 7. So 10 to the power 7 theta, and this cos square theta will be sec square theta, and this will be one again assumption we'll take, t equals to tan theta, because we know tan theta will give you sec square theta. So when we differentiate dt by d theta, it will be sec square theta d theta. Now this sec square theta d theta will be dt now, and what is 1 by a square we'll deal later. 10 raised 7 will be, this is tan theta, so just take the power 7 and integration. What is t raised 7? T raised 8 by 8. So 1 by 8 a square it will be. 1 by a square 8 or 1 by 8 a square. And t raised 8. So let's just write it as 1 by 8 a square. T raised 8 plus constant of integration. What was t? It was tan theta. So tan theta to the power 8 you can write. What was theta? But theta was sine inverse x by a. This tan theta can be written as tan into sine inverse x by a to the power 8. Now we have to convert this sine inverse in terms of tan inverse, so that we can cancel this tan and tan inverse out. That is, tan is already there. Sine inverse x by a can be written as tan inverse x by under root a square minus x square. In the previous question I converted same thing. Here sine inverse was converted to tan inverse, and we have this all formula in r.d.sharma. You can just refer to that. So tan and tan inverse gets cancelled. You get x to the power 8 by under root a square minus x square to the power 8. So 1 by 8 a square was already there. X raised 8 we can write from using the numerator. Denominator is under root a square minus x square to the power 8. What does it mean? So 2 will get cancelled by under root. Basically it's a square minus x square to the power half multiplied by 8. 8 and half multiplied will give you 4. So only a square minus x square to the power 4 will come. This one. Plus constant of integration. That's your result. So this is the way you are going to go about it. So it's you cannot say that this question is simple, because there are multiple logics and algebra things. Assumption has taken place. We have cos 2 cot inverse under root 1 plus x by 1 minus x. So whenever this 1 plus x and 1 minus x or 1 minus x by 1 plus x will come, or wherever we encounter this, we always put x equals to cos 2 theta. You'll see just now. Let's differentiate this. Dx by d theta has given us negative sine 2 theta. And when we differentiate this 2 theta will also be differentiated. That will give you 2. So negative 2 sine 2 theta d theta. Dx is this one. So cos 2 theta, we are not going to use it, but I'm just for the sake of completion. 2 theta will be equal to cos inverse x. Theta will be equal to cos inverse x, half into cos inverse x. So let's do the internal part first. So we have cot inverse. 2 is already there. I'm just doing the cot inverse part. So cot inverse under root 1 plus cos 2 theta divided by 1 minus cos 2 theta. 1 plus cos 2 theta will be what? 2 cos square theta by 2. That is 2 theta by 2 is 2 theta only. And denominator you have 2 sine square 2 theta by 2. That is 2 sine square theta. 2 gets cancelled. Cos square theta by sine square theta. Cos by sine is cot. So it will be cot square sine theta. and cot square theta and under root, because root and square will get cancelled. So cot inverse into cot theta will get. What is there in front? 2. What is in front of that? Cos. So cos 2 theta. Come. Now this dx also has to be changed, and dx will come from here. Negative 2. I'm taking it outside. Sine 2 theta d theta. So cos 2 theta sine 2 theta d theta, and this 2 you can just take inside. Sine 2 theta is 2 sine theta cos theta. So what is 2 sine 2 theta cos 2 theta? You can just swap this cos and sine and then visualize. It will be sine into 2 theta, that is sine 4 theta it will be. Okay. Now this sine 4 theta has come. So there is 2 there also, because this 2 was already there, and we utilize this for this 2 cos 2 theta sine 2 theta, because once we did it, minus 2 sine 2 theta d theta was there, and 2 has come from that only. So negative 2 by 4 cos 4 theta plus constant of integration. We'll not stop it here, because this cos 4 theta has to be integrated now. It has to be converted, because sine 4 theta has already given us cos 4 theta. But what is the relationship? See, cos theta has a relationship. 2 cos square theta by 2, or you can say cos square theta by 2 is 1 plus cos theta by 2. This already you know. So that's how cos theta becomes 2 cos square theta by 2 minus 1. So for cos 4 theta, you have to use this 2, because 2 cos theta is 2 cos square theta by 2 minus 1. So with this cos 4 theta, introduce one more 2. If you introduce this 2 in the numerator, 2 has to be in the denominator also. Because 2 cos 4 theta is 2 cos square 2 theta minus 1, because we are dealing with cos 4 theta now. So now when you introduce 2, you have to introduce 2 in the denominator also. That will form 1 by 4. So this will be 2 cos square 2 theta minus 1. Now multiply this inside. So 2 cos square 2 theta 2 by 4 minus 1 by 4. Now this cos square 2 theta 2 by 4 is half only. But c and minus 1 by 4 will again be a constant. So this cos 2 theta was what? It was x only, if you remember. Initially we have placed x equals to cos 2 theta. So it's cos square 2 theta by 2, that is x square by 2. And c minus 1 by 4 will again be a constant. You can write it as some c prime or capital C. So final answer is nothing but x square by 2 plus constant of integration. So this is the way we are going to do about it. The only thing in this question is x has to be taken as cos 2 theta. That is the first part. And then cos 4 theta has to be converted into 2 cos square 2 theta minus 1. These are two trigonometric relationship, very important for this question. Now we have under root 1 plus x square by x raised 4. So x equals to tan theta we are going to take. Dx will be equal to sec square theta d theta. First thing this one. Now the numerator will become what? 1 plus x square, in place of x square write tan square theta. Denominator we have x raised 4. So tan raised 4 theta. 1 plus tan square theta will be sec square theta. Under root is what? To the power half, that is. So 2 and half will get cancelled. You will get only sec theta. Numerator will be sec theta. Denominator will be tan raised 4 theta. Now x is tan theta. When you integrate it, you have to write something here. In place of dx, you have to replace d theta. So this d theta will be what? See, dx has been replaced by sec square theta d theta now. So you will get sec cube theta divided by tan raised 4 theta. So let's resolve it now. We can write it as 1 by sec cube theta by 1 by cos cube theta. Tan raised 4 theta by sin raised 4 theta by cos raised 4 theta. When it goes up, it will be 1 by cos cube theta multiplied by cos raised 4x goes up, cos raised 4 theta divided by sin raised 4 theta. And this 3 and this 4 will get cancelled. Only 1 cos theta will remain. Denominator you have sin to the power 4 theta. So cos theta divided by sin raised 4 theta. Integration will do this one. This is cos theta divided by sin theta. We can take 1 of it, and rest sin cube theta we can separate it out. Cos theta by sin theta is cot theta. 1 by sin cube theta, this sin cube theta will go up. It will be cosec cube theta. So this whole integration has to be done. We'll take cosec cube theta as t. So this dt by d theta will give you, first of all, 3 cosec square theta. First thing this one. And cosec theta is minus cosec theta cot theta. That you already know. Differentiation of cosec theta is minus cosec theta cot theta. So what is the benefit you are getting? So minus 3 cosec square theta into cosec theta cot theta. So let's combine this. Minus 3 cosec cube theta and cot theta. And the d theta comes here. The dt will be like this. D theta will go there. What about d theta? d theta will be dt by minus 3 cosec square theta or cosec cube theta cot theta, because we need d theta actually. Now we are integrating, okay, that arrow which I just placed. So cot theta, in place of cot theta you can write cot theta cosec cube theta. Let's write it and then we'll cancel it out. This will be dt. In the denominator it will be minus 3 cosec cube theta cot theta. Minus 1 by 3 we can take it outside. The denominator will have cosec cube theta into cot theta. Now let it be cosec cube theta only. Don't change it into t. Now cosec cube theta and cot theta will get cancelled directly here. This gets cancelled. So integration of dt only will come. So what will be that integration of dt? It will be minus 1 by 3, dt will be t only. So minus t by 3 it will come, plus constant of integration. What was t? It was cosec cube theta. Cosec cube theta is t. Minus cosec cube theta by 3. But are you satisfied now? Because there was no theta. Theta was introduced by us. This theta has to be replaced in terms of x. That is, theta will be equal to tan inverse x. So this will become minus cosec cube. And in place of theta, just write tan inverse x. So we'll write this tan inverse x. Now we have to write this tan inverse x in terms of cosec inverse x, so that we can cancel this cosec and cosec inverse. So this is cosec cube theta. Tan inverse can be written as cosec inverse x under root 1 plus x square, because this is a standard result. So tan inverse x will be equal to cosec inverse x under root 1 plus x square by x. This whole cube is there, total cube. So cosec you can cancel, under root 1 plus x square to the power 3 and x to the power 3. So this will be negative 1 by 3 and whole 1 plus x square to the power this x to the power 3 plus constant of integration. That's your final result. So this is the way to write it and formally go about it. Just follow these instructions, and the concept and the logic I've told you. X equals to tan theta one time and t equal to cosec cube theta one time, and then tan inverse x has to be converted into cosec inverse x. That will be under root 1 plus x square by x. That's the whole story of this question. So this is a different kind of question right now. We have 1 by x square plus 2x plus 10 whole square. Now wherever this x square plus 2x will come, just assume that x plus 1 is going to come anyways. That is the tip and trick of this question actually, and most of the question we have x square plus 2x whenever we encounter. So x square plus 2x, if it is combined with 1, it will form x plus 1 whole square. That means a plus b whole square. X is a and 1 is b. So x plus 1 whole square is a square plus b square plus 2ab. This will form x plus 1 whole square. This 9 will be, because only 9 will remain, 10 will form 1 plus 9. So x plus 1 whole square plus 3 square. So 3 square and this whole square, that is, we'll take this x plus 1 as 3 tan theta. Why we have taken it as 3 tan theta? Because when it is combined with 3 square, we can get 1 plus t tan square, and that will form sec square. That is, x plus 1 was taken as 3 tan theta now. So this x plus 1 whole square is 3 square tan square theta plus 3 square. I'm talking about the denominator. 3 square you can take it out. 1 plus tan square theta will form sec square theta now. This will be 3 square sec square theta. And this has the power of 2, because denominator we are dealing right now. So 3 is a 9, 9 is a 27, 27 to the power 2. So let's write 1 by 3 to the power 4. I'm just saying this because I know that there will be certain cancellation which are going to be computed just now. So we have 3 to the power 4 now. So 3 to the power 4 sec to the power 4 theta. And this is your whole denominator. So I have just resolved and completed the denominator explanation. This integration will become integration of this denominator. You can just take this as 3 raised 4. I can take this 3 raised 4 to the outside of integration side, doesn't affect. Sec raised 4 theta remains in here. In place of dx, now we need dx also. So we have to differentiate this x plus 1 equals to 3 tan theta assumption. So this differentiation, x plus 1 will be 1 only. So dx by d theta is going to be equal to 3 tan theta will be sec square theta. So dx has become 3 sec square theta d theta. Now you can just write it here, 3 sec square theta d theta. Now 1 3 cancels out from here. So we are just left with 1 by 3 raised 3, 1 by 3 cube. And this sec square and sec raised 4 will get cancelled. So 2 minus 4 will be negative 2. So sec to the power minus 2, that is 1 by cos square it will be. Or 1 by sec square, because sec raised minus 2 it is. It's 1 by sec square, and sec square will go up and it will form cos square theta. So we are getting cos square in the numerator. So we'll get cos square theta, integration of 1 by 27. Let's write it here. So cos square theta d theta now. Now there is no direct integration of cos square theta, so we know that we can convert it into 1 plus cos 2 theta divided by 2. You already know that. So cos square theta 1 plus cos 2 theta divided by 2. So if you take this 2 cos square theta, you can get 1 plus cos 2 theta. So when you take this 2, or you can write it as cos square theta as 1 plus cos 2 theta by 2, 2 multiplied by 27 will be 1 by 54. We are going to deal this 1 by 54 later. And this 1 plus cos 2 theta will be integration of d theta and integration of cos 2 theta d theta. So this integration of d theta will be theta, and cos 2 theta integration will be sin 2 theta, and in that 2 theta differentiated will be in the denominator plus constant of integration. Now we have to take and change this theta from here. So theta will come from here. Tan theta will be what? X plus 1 divided by 3. Theta will be equal to tan inverse x plus 1 by 3. So just replace theta by tan inverse x plus 1 by 3. So tan inverse x plus 1 by 3 here, plus sin 2 theta by 2. The denominator 2 will deal later. 1 by 54 also has to be dealt later. You have to convert this sin 2 theta into tan form, because we already have tan inverse x plus 1 by 3. So we have to convert this sin 2 theta into tan form. So it will be 2 tan theta divided by 1 plus tan square theta. This you already know. Sin 2 theta is this one. This conversion you know. Again, I'm telling you, sin 2 theta will be equal to 2 tan theta by 1 plus tan square theta. 2 gets cancelled because there was already a 2 in the denominator. So we have already arrived here. X plus 1 we have kept it as 3 tan theta, if you remember. So we have to convert it. So x plus 1 divided by 3 will be equal to tan theta now. So theta will be equal to tan inverse x plus 1 by 3. So we'll write it here. 1 by 54. Then in place of theta, it will be tan inverse x plus 1 by 3. This tan theta, this I'm doing it separately so that we just get the answer and we can put it here nice and clean. So tan theta, theta in place of, we are writing tan inverse x plus 1 by 3. So tan into tan inverse x plus 1 by 3, the first thing. In the denominator, it will be 1 plus tan square theta. So 1 plus tan square of, or tan of tan inverse x plus 1 by 3 whole square, you can call it like that. So I'm writing it like this, tan into tan inverse x plus 1 by 3 to the power square, like this. Tan inverse you can just cancel. Numerator will be x plus 1 by 3. The denominator will be 1 plus x plus 1 by 3 whole square. X plus 1 by 3 whole square. So this is just an algebra now to convert this into a proper simplified form. Denominator, let's do it first. I'm doing the denominator right now. 1 plus x plus 1 whole square, 3 square will be 9. Now cross multiply, 1 into 9 will be 9. Plus this x plus 1 whole square into 1 will be x plus 1 whole square. 9 will be in the denominator. So 9 plus x plus 1 whole square, that is x square plus 1 plus 2x divided by 9. So this will become x square plus 2x plus 10 as in the question by 9. X plus 1 by 3 is already there in the numerator. This 3 and 9 will get cancelled. 3 is a 9. So let me write it the final way. 3 goes up. So 3 into x plus 1 divided by x square plus 2x plus 10. So I'm writing the final one, that is 3 into x plus 1 divided by x square plus 2x plus 1 plus 10, this one, and plus constant of integration. And this is your final answer. That's what the question wanted. So how to go about it? There are certain things. First is the perfect square thing. Now the tip of this question is x plus 1 as 3 tan theta. If you understand that, that will be very, very good. Okay, this is all about this exercise. Thank you so much.